Hi guys, welcome back to my YouTube channel. Today I'll be reviewing gas laws, the various equations, and how to use them. Before we start, let's review the properties of ideal gases. Ideal gases are any substance that exists in the gaseous state at room temperature and pressure. Additionally, they have negligible intermolecular forces, and lastly, their particles are in constant motion. One of the main things you'll need to know in the unit of gas laws is the ideal gas law, which is PV equals nRT. And you need to also know what each of those variables stand for. P stands for pressure, V stands for volume in liters, N stands for moles, R stands for the gas constant, and T stands for the temperature in Kelvin. The reason that this equation works is because there are multiple relationships between each of these properties of gases, all equated using the constant R. Hence, the ideal gas law applies only to ideal gases, and the R value can change depending on the pressure units used. So let's look at some important pressure units to remember. The first is atmospheres, then millimeters mercury, then torrs, then kilopascals, and lastly, pounds per square inch. This last one is rarely used, so I didn't include the R value, but all of the above measurements of pressure are the pressure of 1 atmosphere. So it's also important to know the definition of pressure, which is force exerted per unit area. So in regards to gases, it's the amount of times gas molecules hit the sides of the container that they are in. Once you have a good understanding of the ideal gas law and the various units of pressure and how to convert between them, the next big step is remembering all the other formulas. It might seem like a daunting task, but all gas law formulas can be derived from the ideal gas law equation. All you need to know is how the different characteristics of gases affect the others. Here is a list of the important formulas to know and how they describe the relationships between the various properties of gases. Instead of trying to memorize which one is which, I suggest focusing on what occurs when a certain variable is altered and the others are kept constant. For example, in Boyle's law, volume is inversely proportional to pressure. This occurs when temperature and moles are kept constant. Think of a real-life example where this is true. Think about a balloon, for example. If you put the same amount of air into a bigger balloon as a smaller balloon, the smaller balloon will have a higher pressure than the bigger balloon. And this makes sense because there's more space for the gas to fill up in the larger balloon. So that's why when volume increases, pressure decreases, and if pressure increases, volume decreases. Like this, I suggest finding examples for all the other laws and just remembering how one variable alters another. Now on to some examples. Example number 1. A mixture of gases contains 4.5 moles of neon, 2.2 moles of xenon. Calculate the partial pressure of each gas if the total pressure is 2 atm. To solve this, we can use Dalton's law of partial pressures, which states that the total pressure is equal to the sum of the pressure of each gas. To do this, we must first find the mole fraction of each gas. To do this, we can do 4.5 moles of neon over the moles of neon and moles of xenon added together. This gives us 0.67, so now to find the pressure of neon, we can multiply 2 atm by 0.67 and get a pressure of 1.34 atmospheres. Now, to find the pressure of xenon, we can simply subtract 1.34 from 2 to find that the pressure is 0.66 atmospheres. And reminder that if you want to check your answer, you can always find the mole fraction of xenon and calculate the pressure to see if it matches up. Example 2. A rigid 3-liter container contains some gas at an initial temperature of 25 degrees Celsius and a pressure of 0.94 atmospheres. What is the new pressure if this gas is heated to 45 degrees Celsius? Since the question is asking about the effective temperature on pressure, where moles and volume are held constant, Reminder that this is a rigid container, meaning that the volume stays constant. We can use Gay-Lussac's law. But first, we must convert from temperature. To do so, you need to add 273 to 25 degrees and 45 degrees Celsius to get 298 and 318 degrees Kelvin. Now you simply substitute these values into the equation and solve for the new pressure, which is 1 atm. I hope this helped you better understand gas laws. Thank you so much for watching, and please remember to like and subscribe for more.